Saudi herb Tamarix aphylla has antibacterial capabilities and may solve the pesticide and antifungal misuse problem. Water and ethanolic extract of the aphylla leaves were tested for fungicidal activities against Macrophomina faeculina, Cervularia spicifera, and Fusarium subspecies. GCMS and FTIR were used to determine the aphylla's chemical composition. The poison food assay measured fungal growth inhibition. The aphylla extracts were rich in aromatic and volatile compounds that prove multiple antifungal properties such as benzene, selenol, gibberellic acid, and triazequant. The objective of the study is to evaluate the antifungal properties of the aphylla obtained from the Saudi desert against 5 filamentous fungal species.
Next is the method that we use in this study. There are 3 main methods that we use, which are antifungal assay, scanning of the fungal growth by scanning electron microscopy and transmission electron microscopy, and the third one is Fourier transform infrared spectroscopy. These are the methods used to achieve the objective of this study. The first one is the antifungal assay method, which is done using the poison food technique. This technique allows the researcher to determine the percentage inhibition of mycelial growth of the T. aphylla against the 5 filamentous fungal species. The positive control use of fungicide or right mold that kill or prevent the growth of fungi, and the negative control were made from PDA agar medium only. The next method will be SEM and TEM. SEM is done to test the fungal growth at the minimum inhibitory concentrations and compared to the untreated control. The fungi on the microscope slides went through some process as shown and were coated with a thin layer of gold before visualized by the SEM microscope. The same case for TEM. The fungal samples went through necessary treatment before being able to observe under the TEM microscope. The last one is the FTIR, which is done to investigate the secondary metabolites in the water extract of the T. aphylla that might participate in its fungicidal activities. This tool has the ability to detect simultaneously discrete changes in molecular tissue and composition of tissues. Hence, it is a reliable tool to examine the chemical composition of the samples.
Results here shows the in vitro antifungal activities of Tamarix aphylla leaf extracts against different fungal species on PDA medium. As shown in the figure here, there are 2 treatments involved, which are ethanolic extract and water extract of T. aphylla leaf, and 2 control, which are untreated control and positive fungicide, which is ridomil. Based on the results, all treatment shows an obvious inhibition of the mycelial growth of every species. Tables here shows the diameter of mycelial growth of different phytopathogenic fungi at 30% concentration of water extract, ethanolic extract, and at 1 mg per ml of ridomil. From the result, it shows the inhibitory effects on the mycelial growth of the fungal species are greater in ethanolic extracts compared to water extracts. Next is FTIR analysis of water extract of T. aphylla. FTIR analysis is used to identify the molecular compounds. This analysis works by measuring the absorbance of infrared radiation by a sample. From the results, white peaks at 3,422 cm to the power of -1 and 2,932 cm to the power of -1 are resulted from the expansion of single bond OH. At 1,622 cm to the power of -1, the peak shows the expansion of carbon-carbon double bond of alpha-beta unsaturated ketone. The result also shows the SEM and TEM scanning of Macrophomina faeculina, as from this study, this species had the most robust inhibition of mycelial growth compared to the other species. Image A is the SEM image of untreated M. faeculina, while B and C shows the effect of water and ethanolic extract of T. aphylla to M. faeculina respectively. From these images, both ethanolic and water extracts of T. aphylla ruptured and thickened the mycelia of M. faeculina. Finally, in TEM, the treated M. faeculina in image B and C shows the accumulation of white vacuoles that induce the rupture of the cellular wall.
According to the article, we focus on 3 key results for discussion. Firstly, the antifungal assay demonstrated that extract from T. aphylla exhibit antifungal properties against various phytopathogenic fungi. Both ethanolic and water extract showed a significant inhibition at different concentrations with the water extract being the most effective against M. fasciolina, resulting in nearly 60% inhibition compared to the control. Secondly, TEM and SEM scanning technique were employed to examine M. fasciolina, which exhibit the most noticeable inhibition zones. The microscopic images revealed significant structural alteration in the mycelial and conidial structures of the treated fungus. These changes include cellular damage, elongated hyphae, poor staining absorption, disruption in spore formation, and transition from the color grey to off-white puffy, and also elevated mycelia. These observations indicate that the aphylla extract induce ultrastructural modification that impede fungal growth. Lastly, FTIR analysis was conducted as a preliminary screening and identified the presence of flavonoid, sterol, terpenoids, alkaloid, and tannins in the stem bark of the aphylla. These secondary metabolites are known to possess various pharmacological activity. Phenolic, phytochemical, and organic acid exhibit antimicrobial effect by inducing acidification of the microorganisms, plasma membrane, and cytosol. This compound may also impact the fluidity and the stability of the plasma membranes, leading to partial disruption. However, it is important to consider that other factors and biochemical processes can influence the biological activity of these antimicrobial compounds when interacting with microbial cells and plant tissues. Hence, the present study highlights the antifungal activities of Saudi native grown plant, but further research is required to understand the spectrum of the fungus susceptibility to the extract.
The research proven that the water and ethylene extract of the aphylla might work as antifungal agents against some pathogenic fungi. The phytochemical composition of the aphylla is rich in aromatic compounds, secondary metabolites, alkaloids, and flavonoids. Further studies need to be performed to classify the range of the fungal sensitivity in